Ladies and gentlemen, thank you for the kind invitation. It's a great opportunity to speak to such excellent and admirable people like you who are willing to spread the idea of passive houses all around the globe. My name is Benjamin Krick. I am member of the scientific staff of the Passivhaus Institut in Darmstadt. I am the chairman of the Component Certifiers division of the Passivhaus Institut. Today, my topic is about passive house windows for Mediterranean climates. As you might know, the certification criteria of passive house windows in the cool temperate climate is 0.8 watt per square meter Kelvin. If we are going to warmer climates, then the requirements on passive house windows are decreasing because of the warmer temperature. So in the Mediterranean area, you don't need such excellent U values like 0.8 watt per square meter Kelvin. The question is, what U value is affordable for these climates? We have done some researches on that, and I will show you the results. I want to show you how we are designing our certification criteria. First criterion is about comfort. If you have very low temperatures on the outside of the building, low surface temperature at the inner side of the building can occur. And this low surface temperatures are causing radiation losses and cold downdrafts, and that is unpleasant, that is uncomfortable. So if you look at these numbers, minus 12 degrees centigrade on the outside of the building, that's not a temperature which often occurs in your climate. This is a temperature which occurs in the cool temperate climate, in the climate of Germany, for instance. On the other hand, you are using single glazed windows in this area to achieve the high quality indoor comfort we need in passive houses. The outside temperature might not be lower than 15.5 degrees centigrade. If the outside temperature is lower than that, the single glazing is not affordable anymore. So you need better glazing and better windows. In the Mediterranean climate too. The common solution for this problem is to have a radiator beneath the window, and this radiator will create an upstream that compensates the downdraft, and it warms up the pane, and so the radiation losses are reduced. The indoor climate might be comfortable. At passive houses, we are grabbing this problem by its root. We are improving the thermal quality of the building's envelope by using triple panes and insulated frames to prevent this downdraft and these radiation losses by raising up the surface temperature. In doing so, we are reducing the thermal losses of the building, so it's possible to bring the little amount of energy for heating by the air supply system, and we can cool by this air supply system too. That is the definition of the passive house. It has to be possible to cool and to heat the house only by the in hygienical matters needed fresh air. By having this opportunity, the whole system for the building service gets cheaper, and this is a very important point for the affordability of passive houses. And this point where the radiation losses and the downdraft doesn't occur anymore in an unpleasant manner, it's if the temperature difference between the operative room temperature and the surface temperature is not bigger as 4.2 Kelvin. So the criterion for the comfort in passive houses is that the minimum temperature of the inner surfaces might not be less 4.2 Kelvin than the operative room temperature. And this is a climate independent definition, but it depends on the outside climate, how high the quality of the thermal envelope has to be. We see here the maximum U value allowed to catch this comfort criterion, and on the other axis we see the design temperature. In Frankfurt we have this commonly known U value of the installed window of 0.85 watt per square meter Kelvin that refers to an outdoor temperature of minus 16 degrees centigrade. If we are going to a warmer climate like Rome in Italy, then we only have to achieve 1.35 watt per square meter Kelvin to catch the comfort criterion, and that is about outside temperature of 2 degrees centigrade. If we're going to colder climates like Warsaw, the U value of the installed window has to decrease to, in this example, 0.67 watt per square meter Kelvin. And if we are going to Moscow in Russia, then we have to achieve 0.6 watt per square meter Kelvin. This criterion is independent from the climate, but the U values which are resulting from this criterion are different to each climate. If we have a look to whole Europe, we can display on a map the required U values of the installed window all over Europe. And when we see that we need in Scandinavia and in Russia very low U values of the installed window, like 0.4, going to East Europe and Scandinavia with 0.6 watt per square meter Kelvin, 2 in parts of the Alps, and then to this common known area where we need 0.8 watt per square meter Kelvin, to the more Mediterranean climates, we have to achieve only 1.0 or 1.2 watt per square meter Kelvins. This is about comfort. And we see that here in Spain or in parts of Italy, we only need U values more than 2.2. But might be this isn't reasonable in terms of economy. We will have a look at this later. To catch this comfort criterion, we have the possibility to use double, triple and quadruple glazing. This map shows which glazing in what region is used best. And we see that in the north of Europe and the east, we need quadruple glazing. In the south and west of Europe, double glazing is okay. But in most parts of Europe, we need the triple glazing. The next criterion is the hygiene criterion. Catching the hygiene criterion means to prevent mold and condensation at the inner surfaces of the building. To catch this criterion, it's necessary to keep the maximum water activity AW lower than 0.8. The maximum water activity is nothing else than the relative humidity of the air inside a pore of a material or directly above it. The maximum water activity can be displayed by the temperature factor FRSI. This temperature factor is climate dependent. In Germany, we need a temperature factor of 0.7 to prevent mold, and in warmer climates like Rome, it's only 0.5. If the climate gets colder, like in Warsaw, we need 0.75, and in Moscow, in Russia, we need at this very cold climate 0.8 for the temperature factor, and that's very hard to reach. We see again, the milder the climate is, the lower is the requirement. The next point is about economy. Which glazing and which frame is in economic matters the best for what climate of Europe? Together with the little window cooperative Pro Passivhaus-Fenster, the Passivhaus Institut has set up a little study in which we have given an answer to that question. We had a look at this SmartWin window. SmartWin Compact is the name of this window, one with double glazing and another with triple glazing and even with quadruple glazing. We have two kinds of triple glazing here. A solar optimized, this one here, a solar optimized glazing and a U value optimized glazing, and the same for the quadruple glazing. We did the study for two different types of buildings. First type of building is the Passivhaus in Kranichstein. It's a row house, it's south-oriented and has very big south-oriented windows, so very high solar gain. The other example is a highly shaded townhouse. It's east-west oriented and has small windows, so we haven't so much solar gain, so it's a completely different type of building. Looking at the results, we see for the Passivhaus Kranichstein that the U-value optimized glazing is dominating most of Europe. Only in little parts of Europe it's the solar optimized triple glazing, and the double glazing plays a minor role. But please note, in this area of Scandinavia, the passive house is not the economic optimum. So we have in this area here triple glazing too, but we need, in terms of comfort, quadruple glazing. If we are looking to the townhouse, then the picture is a bit different. We see here in the Scandinavian area, the optimum is the quadruple glazing. This is because we have here smaller windows, less solar gains, so it is affordable to invest in this better glazing. But the whole rest of Europe is triple glazing. Only here in this small, very small areas, we see there is double glazing. But we have done this simulations with German prices. So if we take into account this real prices of glazing in the south of Europe, this will lead to double glazing in south of Europe, and this we have to consider in our criteria. This consideration were leading us to the displayed map of the Mediterranean area. We have designed this map in the projects Parsec and 3&Cult together with our partners. The blue areas are the cool temperate climate with the already known U value for the installed window of 0.85 watt per square meter Kelvin and the reference glazing of 0.7 and the hygiene criterion of 0.7. The warm temperate climate have to achieve 0.05 watt per square meter Kelvin for the installed window with a reference glazing of 0.9, which can be achieved by an air-filled triple glazing or by a very good double glazing with an exterior hard coating. The yellow area is the warm climate zone. There we need a U value for the installed window of 1.25 watt per square meter Kelvin, and we can use a double glazing. The temperature factor has to be 0.55, and the hot climate is to the U installed value of 0.25 watt per square meter Kelvin, but there an anti-sun glazing might be the best option. And the hot climate here in the regions of Africa, we need 1.05 watt per square meter Kelvin, again a triple glazing, but this time as an anti-sun glazing. Examples for windows for the different climate zones are displayed in this sheet. We see here a window for the cool temperate climate with an insulation layer in front of the window. In the warm temperate climate, we don't need this insulation layer. It achieves the required U value without it. And for the warm climate, it's more or less the same window with a double glazing. For this type of window, for this common wooden timber window, we need the insulation. For the cool temperate climate, for the warm temperate climate, we don't need the insulation layer, and it's again more or less the same window than for the warm climate and for the warm temperate climate, but with a double glazing. This is what I want to show you today. I want to thank you for your kind attention, and I want to invite you to a window workshop for specialists held at the 19th International Passive Conference in the city of Leipzig in April next year. And there, Franz Freundorfer, a window expert, and me, we are showing you how to design very efficient and affordable windows for passive houses. I wish you a pleasant day and a pleasant conference. Thank you.